All right, hello everyone. Welcome to my poster presentation where today I'm going to talk about how we use our microbiome data from this curated data resource of 214,000 metagenomic samples to characterize the global antimicrobial resistome. My name is Martiny. I come from the Technical University of Denmark, specifically in the research group for genomic epidemiology. So this is my poster here. I'm just going to walk you quickly through it. It's also uploaded on the website, and I suggest you come talk to me if you are at the conference in person. So antimicrobial resistance is becoming a very big global health threat. Actually, there's this report from 2016 that estimated that by the time we reach the year of 2050, there will be about 10 million deaths annually due to antimicrobial resistance or AMR. There's also this report that came out last year that estimated that in 2019 they could directly associate almost 5 million deaths due to AMR, and of these they could directly attribute 1.3 million of them. So this is becoming such a big problem that we need to figure out how we can actually monitor the abundance of antimicrobial resistance. With this work here, we are seeking to create a global collection of samples that spans the world, multiple environments, multiple years. And we are doing this by retrieving sequencing data from the public data repository, European Nucleotide Archive. You see there's a lot of data here on the graph, a lot of sequencing ones available on ENA. We retrieve all the data from 2010 to 2020, currently working on updating this collection. And here I just wanted you to walk through all this work we've been doing in order to utilize all this data. Here's our pipeline we currently are developing and trying to get a manuscript published on it. We are retrieving the data, the sequencing reads, we are trimming them, and then we are currently doing three kind of things. We're looking at the mapping and alignment of reads against reference sequence databases. We are building targeted assemblies around antimicrobial resistant genes with our ARC extender tool, and then we're also trying to create regional representations by producing mass sketches. This is currently in press. We are trying to put the pipeline out there. Our curated data resource was actually first published last year in PLOS Biology in 2022, where we are describing our efforts to analyze all this data. We retrieved more than 442 tera base pairs of sequencing reads. We found that there was a lot of read fragments that aligned both to resistant genes, but also to rRNA genes. You can also see here from the plot, but there seems to be different distribution of antimicrobial resistant genes depending on whether you look at location or source. I can add that the data is actually publicly available on Zenodo, and I suggest you go and look it up and read the paper, of course. So with this fourth part of the poster, I wanted to showcase our study of where we really dug into the data to look for mobilized cholesterol resistant genes. And we wanted to look at the distribution of these genes across source, location, and time. And we actually found that a lot of these genes seem to have been circulating years before their discovery. We also show that there seems to be the reason for the spread seems to be highly suggested of the source and location and how these genes have been spread around the world. We also found that there is some evidence of some new subvariants already circulating. This paper came out last year also in Systems, and it showcases how we can use all of this data in a lot of different ways. In the fifth part of my poster here, I wanted to show how we can do more global characterization of antimicrobial resistant genes instead of just looking at a subset of genes. So with this study here, we wanted to infer how resistant genes they are being co-abundant with each other, or how they co-occur with each other, independent on which microbe they sit in. So we show that there are several resistant genes that are strongly indirectly select for each other. we show, for example, that these all these correlations, they can be used as a risk profile to create risk profiles for resistance. And by that I mean, if we look at, for example, if I were to use tetracycline in an environment, what would happen to the resistome in there? Would I indirectly select for a lot of different kind of resistant genes otherwise, or what would actually happen? This paper is only out as a preprint on Borrow archive, but we argue that it could actually maybe serve as a way to guide future usage of antibiotics in different environments. Finally, we're also looking into this new group of genes that we are collaborating with the Chapel group on. They work to identify genes that confer resistance to antibiotics and are not yet on the market. We are currently looking into the distribution in sugared samples, but also expanding it to all these different other kind of samples. So I hope with this poster here that I might have sparked some ideas in how we can use this data, because we believe that there is a large untapped potential in reusing all this data. We are showcasing some of what we're doing, but we are thinking this is only the beginning. We are very eager to hear all of your ideas on how we can use this data. Of course, we can keep focusing on resistance, but we also have the microbiome abundances in this kind of analysis. I would love to hear how you think you can use the data collection. I suggest you talk to me in person at the conference, or you're welcome to reach out by my contact details. Thank you so much for listening.